Hi, welcome to my third video for Wallap. So today what I'm going to do is I'm going to install a strut and it's again a wall, but this time I'm going to have 5 stages, and I have 2 struts, and I have this excavation in 2 stages. So these are the soil properties I'm going to use. This time it's a little bit complex soil layers. That means I have 4 soil layers, and these are the wall properties, and these are the strut properties that I'm going to use. So the first thing is, so I started a new data set, and I'm going to define the my spectrum. So the first layer is at negative 7.1.7, 2, 2, and next one is negative 2.9, 3, 3. Next one is at negative 4.9, 4, and the final one at negative 10. So this is again 4. So then I'm going to define my soil properties. First one is my fill. And, the density is 19, and soil is cohesionless. Okay, sorry, I mistakenly put this value, so it should be friction angle 25, and soil cohesion is 0, and then the angle is 25, so I need to find K naught value. So 1 minus sine 25, that gives me 0.577, and these are my K and Kc values. So angle is 25, and I just need to accept it here. So here also I need to change the angle. Angle is 25, and accept it. Didn't go. Angle is 25. Click accept, and then Young modulus is 25, and percent ratio is 0.3. So likewise, you need to fill all these 4 soil layers. So I'm going to do one by one. And second layer, 19, the clay one, 19, cohesive or consolidated, then K naught is 1 minus sine phi, that means 30, it means 0.5, and 0, Ka is 0.333, 0, Kp is 3, 0, and drain cohesion is 30, 0, and Young modulus is 15 MPa, and that means 15,000 kPa. It's not varying with the depth, and Poisson ratio is 0.3. Then soil type 2, clay 2, density 22, unit weight 22, cohesive or consolidated, drain K naught is again the angle is 35, 1 minus sine 35 gives me 0.426, and it is not varying with the depth. And K value, you can press F1 and put friction angle here, and it will automatically calculate it. And cohesion is 30, and it's not varying with depth. Now modulus is 50 MPa, 50,000 kPa, and Poisson ratio is 0.3. Okay, so we are going to define our last layer, granite, 24, 24, cohesive, over consolidated, drain, K naught again 0.426. It's not varying with depth. Ka, press F1, this is 35, and friction angle is 35. So I have been explaining this, how to put these values one by one in my first two videos as well. So I don't think there's nothing new here. So we just enter the properties, and yeah. So we already defined the properties, but there is incompatibility in here. So we will go here, check that one. So this is 30, accept it. So there are no errors. So you saw that there were two errors. So if you have any errors, you need to go back and check what's the problem in there. And our initial groundwater table is at 1.7 below the ground surface. So that's 1.7, and I'm not changing the water table, that means the water groundwater table, and I have a fully embedded wall, and the wall height is 4.5, and the Young modulus is 20 GPa, and moment of inertia is 0.0104. So it's thickness is 0.5, thickness into the power 3 divided by 12. And next I'm going to put the strut properties. So I have one strut at elevation 1.35, strut spacing is 1, and area is 0.15. Young modulus is 30 GPa. So 3E7, free length is 6 meters, and I'm going to assume this one as horizontal, and no pretension, not tension allowed. And I'm having another strut at elevation 3.2, negative 3.2, with the same properties, 1 meter, 0.15, 3E7, free length is 6, inclination angle is 0, and there is no pre-stress, and tension is not allowed. So I'm going to define the surcharge again. Surcharge is at ground surface, and distance, zero distance from the wall, and I'm going to have, okay, so this is, I'm going to apply this one, length parallel to 20 meter. Actually I wanted to put this one in the passive side, so and 24 kilonewton per meter square. So the surcharge is on the active side, and I'm going to define the stages. First one is excavate, applying the surcharge, applying the surcharge. It's one. So it's applied on the active side, and then I'm going to insert my second stage, excavate on the sorry, if this happens you need to go back. I just put this value and go back and change that one. I actually want to excavate the passive side of the wall, and I want to do it at the elevation of 1.9, negative 1.9. And then I'm going to apply a strut. So install a strut anchor number 1. So it's installed, and I'm going to need all these output properties. So I'm going to say yes. And I'm going to put the fourth stage. I'm going to excavate this one to the level of 3.75, and I'm going to need all these graphical outputs and information about the analysis. So our last stage is to install the last strut. So strut number 2. And I will use PSC handbook calculations, and I want factor of safety of 2. And I will use all the other values, the default values. And so I want all these graphical outputs. I want to make them yes. Make this one yes. Yes. And finally, everything is settled. You can check all these your stages. So first stage, apply the surcharge. Second stage, excavate to the level of 1.9. Third one is apply the strut number 1. Second one is excavate further up to 3.75. The next one is apply this strut. So I'm going to analyze this data and see. So I need to save it. So I'm going to save the file. So it's already saved, and I'm getting a maximum deflection of 13 millimeters on top. And this is my bending moment and shear force diagram. So like I showed last time, you can create a report from here. And this is in progress like that. And each and every stage, all these diagrams you can have a look. So you can view the report from here. So it's basically a RTF format file. So you need to save it as a Word document if you want to take this one out. So all the input values we input are here. And if you want, you can have a snapshot of this one and repeat the same. So these are all the things you need to repeat the same problem that I did. So this is the stage number 5 diagram. And if you go to the end of this Word document, you will see this is your final outcome. So it's 13 millimeters deformation at the top. So I hope you enjoy this analysis. If you have any questions, you can post it in my video comment as a video comment. Thank you for listening.